In this video, we're going to be continuing the circulatory system, starting with define arteries. So arteries are blood vessels that take blood away from the heart. Stupid memory trick, artery and away both start with A, so if it helps you to remember that, remember the away and artery go together. Arterioles are small arteries that take blood to capillary beds. Capillaries are the smallest blood vessels. And the other thing you need to know about capillaries is they are the blood vessels that actually participate in exchange. So earlier we talked about all the important things that blood is transporting. Once we've transported it, we have to drop it off. And capillaries are the place where we drop off oxygen and we pick up carbon dioxide and we drop off nutrients and we pick up wastes. Capillaries are really the only vessels that are designed to participate in that exchange. And so that's their job. Interstitial fluid is the fluid between the cells. When I say that the capillaries are dropping things off at the cells, what I really mean is they drop it off at the interstitial fluid, and then the cells can pick up and drop off from the interstitial fluid. So that fluid is sort of the mediator that allows for exchange between the blood vessels and then the tissue cells. Venules are the small veins that drain blood from a capillary bed, and then they merge together to create veins. And the definition for a vein is it's a blood vessel that takes blood back to the heart. Let's see, why aren't you moving, slide? Let me come over here and click. You don't want to do it over here either? There we go. My computer's being weird on me. So I gave you this picture. This picture is actually from an anatomy textbook, but I have tried to take out some of the slightly more complicated labels for you. So believe it or not, this is the easier version of what I want you guys to know. We're doing this in lab as well. So all of these terms are terms that you get in lab as well as lecture. So since in lab I really talk about the chambers, the valves, and the vessels, in this one I'm going to run you through the pathway of blood and talk about the deoxygenation and oxygenation process. So everything that's depicted in blue, the reason it's blue is it's trying to tell you that the blood is deoxygenated on that side, which means, yeah, there's a little bit of oxygen in there, but not very much, so it's oxygen poor. Everything in red is trying to show you that the blood is oxygenated or oxygen rich. Now, in a lot of cases, arteries are going to be red and veins are going to be blue, but that's not really true around what's known as the pulmonary circuit. So you need to remember the color isn't about artery and vein. The color is about, do we have oxygen, yes or no? So blue means no, red means yes. So blood is going to be entering the heart on the right side in a deoxygenated state through the superior and the inferior vena cava into the heart in the right atrium. The right atrium can pump the blood through the tricuspid valve into the right ventricle. The right ventricle pumps the blood through the pulmonary valve into the pulmonary trunk, which splits into the pulmonary arteries, which are going to take the blood to the lungs. The lungs are, of course, where we pick up oxygen and drop off carbon dioxide, so I'm going to change colors to indicate we're coming back in an oxygenated state. We come back in through the pulmonary veins into the left atrium. The left atrium pumps the blood through the bicuspid valve, which is also called the mitral valve, into the left ventricle. The left ventricle pumps the blood through the aortic valve and then into the aorta, which is the largest vessel in terms of diameter, and it's also the vessel that has the highest blood pressure out of any blood vessel that you have in your body. This vessel actually loops around, goes behind the heart, and then it comes back out under here. So this is also the aorta off down there. The aorta distributes blood to everywhere in the body, and then we drop off oxygen, pick up CO2, and then we come back in through the vena cavas on this side. Now do remember, you can pause the video to get whatever labels you didn't have time to write down as I was going through that. Rewatch it a few times so that you can make sure you understand the pathway of blood as well. I'll stay on this slide, I guess, for the next one. Which side of the heart pumps oxygenated blood? That will be the left side, which is also called the systemic circuit. Which side pumps deoxygenated blood? That would be the right side, which is also known as the pulmonary circuit. What is the name of the largest artery in the body? That would be the aorta, which is labeled for you up here. What is the function of the valves in the heart? So this one's an important one. Blood moves as a result of pressure differentials. It always wants to move from a high pressure area to a low pressure area. What the valves do is prevent the blood from moving backwards, because very often the lowest pressure is actually where we just came from. And so we don't want the blood to move backwards, we want to keep it moving forward. So here's what that's going to mean for us. Erase all ink. I'm going to start back over. I'm going to switch to this nice little color. So when the right ventricle pumps the blood through the tricuspid valve into the right ventricle, life is all nice and happy. That door is open and our blood can move through here. When the right ventricle pumps the blood, though, here's our issue. Pressure in this right atrium is now really low, and so the blood would like to go back into that chamber when the ventricle contracts, but we don't want it to go backwards. So when the right ventricle contracts, that pressure slams this door shut so that the blood has no choice but to go through the pulmonary valve, which is going to open as a result of the right ventricle contracting. Then, when the right ventricle relaxes, blood wants to fall back down into the right ventricle because pressure is low down here. That's what slams this door shut and keeps the blood moving in a forward direction. So your short answer is the valves prevent the blood from moving backwards in the heart. And then I gave you that longer explanation sort of as I went through there. Ooh, and I skipped something. I didn't even realize. Let's go back so that I can talk about it. So before the function of the valves in the heart, I was supposed to mention, what do the coronary arteries do? The coronary arteries supply functional blood to the heart. And when I say functional blood, I mean oxygen-rich, nutrient-rich, low levels of carbon dioxide, and low levels of waste. Even though the heart is filled with blood all the time, the blood that's in the heart doesn't actually help the heart. It doesn't supply the heart with the oxygen that it needs and the nutrient that it needs. So the coronary arteries do that for us. So there's a whole bunch of blood vessels on the surface of the heart, and they're supplying the heart with that functional blood that they need to survive. Now, one of the problems is if a person starts to build up too much cholesterol or plaque in their blood vessels, that can block off the coronary arteries, which means the area distal to that site is no longer receiving functional blood. If tissue doesn't get oxygen, it dies. That's what a heart attack is. You're killing part of the heart because something is blocking blood flow in the coronary vessels. You can even see on this heart off over here, this is all fibrotic tissue, which means it's dead heart that's been replaced by scar tissue. And so this happened as a result of, it looks like there was a blockage right here that was supposed to be supplying us. There was probably a blockage someplace up here, maybe right there too, but it would be hard to tell without a microscope. So the coronary arteries are supposed to prevent that, but if you have a crappy diet and you don't exercise, this is what's happening, and it's going to end up making you pay the piper later on. So I already mentioned what the heart valves do earlier, but this is a picture, and this is what I always super love about this picture. This is a Cocker Spaniel getting open heart surgery, because what I have learned is people who own Cocker Spaniels apparently have lots of money and they really, really love their dogs, and so they get to have open heart surgery. This is the tricuspid valve, and this valve is actually perfectly okay. We've got our three cusps, they're nice and clean, that door closes like it's supposed to. This is the bicuspid valve. It is supposed to have two cusps because it's the bicuspid valve, but we've got this extra little thing over here which is called a vegetation. That is preventing the door from closing, and if the door can't close, that means blood can backflow through the heart. So the dog would have had a heart murmur, and there's symptoms that can go along with that because the heart keeps having to repump the same blood over and over and over again if a heart valve fails. So that's why you need them to function like they're supposed to. Okay. SA node stands for the sinoatrial node. Here's how you spell sinoatrial. The SA node is the pacemaker for the heart. So the heart beats all on its own. It keeps its own rhythm. It does not need to be told what to do by the nervous system. Although the nervous system can speed things up or slow it down, the SA node has ultimate control over what the heart rate is going to be. So that's why it's called the pacemaker of the heart. Once this sinoatrial node fires off an impulse, that impulse gets relayed to the AV node. The AV node relays the signal down to the ventricles. So the SA node makes the atria contract. The AV node makes the ventricles contract. After that, cardiac output is the amount of blood the heart pumps in 1 minute. On average, it ends up being about 5 liters per minute, which is approximately equal to your total blood volume, which means your heart is pumping all of your blood every minute of every day when you're at rest. Cardiac output actually goes up when you're exercising, and so that just shows you how hard your heart has to work every day. Okay, then we come back to blood vessels again. What type of tissues make up the walls of blood vessels? Well, we have epithelial tissue that's in direct contact with the blood. We have smooth muscle that helps propel the blood forward. And then we have connective tissue that makes the blood vessels sort of elastic. Especially on the arterial side, we have really high pressure there. And that high pressure can make the arteries expand like a balloon, so we need them to be elastic so they can expand. The veins don't have quite as much of that tissue on their side, especially the smooth muscle, they don't have as much. Let's see. Is that the end of that chapter? No, it's not. I just have a thing that's in my way right now. Okay. What do veins have that arteries don't? They have valves, and you can see that right here in this picture. The pressure on the venous side of your circulation is so crazy low that there's very little that's trying to make your blood move in a forward direction. So if you get your blood up past a certain point, gravity makes it want to fall back down. So we have these valves that do the same thing in veins that they do in the heart, and that is it prevents blood from falling back down. What type of blood vessel actually allows exchange of materials between blood and body tissues? We mentioned that earlier. It's capillaries. Then, define blood pressure. It is the pressure of the blood within the vessels. What generates blood pressure is the heart. Systolic pressure is the top number in a blood pressure reading. Systolic pressure is the pressure when the heart's contracting. Diastolic pressure is the lower number in a blood pressure reading, and that is the pressure of the blood when the heart's relaxed. What is considered to be a healthy average blood pressure? It should be somewhere around 120/80. It can vary depending on whether you're exercising or not, and on a bunch of other factors as well, but on average 120/80 is considered to be healthy. This blood pressure that I'm showing you here is what's known as hypertensive. That means a person has high blood pressure, and that puts a person at risk of a bunch of different diseases. Next, some diseases of the circulatory system. Anemia means that a person is not transporting oxygen like they're supposed to. The most common symptoms that are associated with anemia are fatigue, which is the person feels tired all the time, and they often feel cold all the time as well. There's a bunch of different reasons why a person might be anemic, but by far the most common is what's known as iron deficiency anemia, which is they're not getting enough iron in their diet. Iron supplementation can help with that, or a diet change can help with that. The reason for this picture off over here is one of the other reasons why a person might be anemic is what's known as hemorrhagic anemia, which is if your blood is on the floor, it's not helping you transport oxygen very well. And so that's another type of anemia that can happen. There's a bunch of others as well. These are just some of the more common forms. Atherosclerosis is hardening of the arteries, often as a result of a buildup of plaque in the wall of the artery. Atherosclerosis makes hypertension more common, and it also makes blood clotting more likely to happen, and that puts a person at a dramatically increased risk of suffering a heart attack or a stroke. And so atherosclerosis is something we want to avoid. The way that we avoid it is by eating a good diet that is low in fat and low in sugar. Heart attacks occur when the coronary circulation gets blocked somehow. So we mentioned plaques and the coronary circulation all earlier, but what's actually happening in a heart attack is, again, heart muscle is dying. If part of your heart is dying, that means it's not going to be able to maintain blood pressure like it's supposed to, which can kill you as a whole. So if you have a heart attack, you can flat out die as a result of that dead in heart muscle tissue. The most important thing that you can do to reduce your risk of heart attack is keep your blood pressure where it's supposed to be. Arrhythmia is an irregular heart rhythm. So ordinarily, if a person is listening to you or taking a pulse, you should have a nice, like, metronomic heart rhythm. If it's fast and then slow, or slow and then fast, that's a sign of arrhythmia, and that means your pacemaker is not keeping a pace like it's supposed to, and that can set the stage for something known as fibrillation, which is not okay. And so heart rhythm should be nice and regular. An aneurysm is when a blood vessel balloons out and it doesn't maintain its shape quite like it's supposed to. The risk of an aneurysm is like an overinflated balloon. It can pop. So I don't know how much you guys remember of this dude. His name was John Ritter. He was on a 70s show called, oh my God, what was it? Three's Company. And then he was on a bunch of other shows later on, like he was JD's father in Scrubs, and he played a lot of characters. He died very spontaneously while he was grocery shopping one day of an aortic ruptured aneurysm. And what that meant was, hey, his aorta, which I mentioned earlier, the aorta has the highest pressure of any vessel in the body. His ruptured on him in the grocery store, and he was dead in 5 minutes because the pressure is so high, you bleed out really fast from that. This is something that you increase your risk of if you have hypertension, and so you want to try to avoid hypertension to prevent this as well. After that, we have a really, really brief blurb on the lymph system. So your lymph system's job is to return fluid back to the circulatory system, because as it turns out, your capillaries are really leaky. That leakiness helps them do their job of transporting materials, but the problem is when you leak fluid out, that fluid just sits around in between these cells, and if that continued to happen and you didn't return that fluid back to circulation, your blood pressure would drop and you'd die. So we need a mechanism to get that fluid back to the circulatory system, and that's the lymph system's job. What happens is when fluid builds up around tissue cells, that fluid eventually leaks into a lymph capillary, and then the lymph system transports it back to the circulatory system. So lymph capillaries are the smallest lymph vessels. They pick up interstitial fluid, and once that fluid is picked up, the name changes and it is called lymph. So lymph is really the same thing as blood plasma, and it's the same thing as interstitial fluid. Its location is just different. So when the fluid's inside a blood vessel, it's called plasma. When the fluid's between cells, it's called interstitial fluid. And when the fluid is inside a lymph vessel, it's called lymph. Because the lymph can pick up dangerous things as it's traveling through your body, and by dangerous things, I generally mean pathogens like bacteria. We want to filter that lymph before we dump it back into the circulatory system. So scattered around through all of the lymph system, we have these little kidney bean shaped things that are called lymph nodes. And we put a bunch of white blood cells in those lymph nodes so that they can eat any pathogens that are traveling through the lymph, so that as the lymph gets dumped back into the circulatory system, it's clean again. Last, edema is fluid swelling. One of the reasons that edema can happen is because the lymph system is not taking fluid back to the circulatory system like it's supposed to. So let's talk about some of these pictures. This person up here has something that's called pitting edema. This type of edema is most likely to occur as a result of heart failure, because the right side of the heart and the left side of the heart are ordinarily supposed to pump the same amount of blood. If you have a heart attack, that means one of the sides isn't keeping up with the other side, and so fluid backs up before the side that's failing. When you get pitting edema, it means that the right side of the heart is failing. This is one of our types of congestive heart failure. Now, down here in this one, this woman, and I'm sorry the picture is so blurry, but this woman had cancer. And the cancer had spread to her lymph nodes. And so they had to remove a portion of her lymph system because the cancer had spread. Because the whole purpose of the lymph system is to take fluid back to the circulatory system, removal of that meant that fluid couldn't get where it was supposed to go. And so basically, she swelled up like a water balloon because the fluid couldn't escape like it was supposed to. Now, to treat this, ordinarily we would put shunts in there to drain that fluid. We can also do something called combined decongestive therapy, which is where we put like compression socks in a person, and we have these inflatable booties that we can put on them to try to squeeze the fluid back up to where it's supposed to go. But given enough time, you will grow new lymph vessels. You grow new blood vessels and new lymph vessels all the time. And so this is her several weeks after she had the surgery. And notice the swelling's gone because she has rebuilt her lymph vessels at that point. Finally, the last case of edema that I'm going to give you is the weirdest, and it's also the one that everybody thinks they know the name of, but they don't. Most people call this elephantitis, and elephantitis would mean that your elephant is inflamed, and you don't have an elephant, I'm going to bet. Instead, this is elephantiasis, which means that you have swelled up so much that you look like an elephant, which is unfortunately what happens here. Elephantiasis happens because of a parasitic worm infection. This is called a filarial worm. This worm likes to travel around through your lymph system, and unfortunately, they tend to get stuck in some of the smaller lymph vessels. And when they get stuck, everything south of that point the fluid can't get up anymore. It's stuck down here. And because the worm moves, you can't grow lymph vessels fast enough to fix the problem that's happening. And so this condition just gets worse and worse and worse, and it's horribly unpleasant when you have it. You don't see elephantiasis in the United States because if you started to swell up like this, I would like to think you'd go to the doctor. The doctor would give you an antiparasitic that would take care of your problem. If you go to poorer countries and places where they have these parasites, they very often don't have the medical care necessary to take care of that worm. So here's where I'm going to tell you the really gross part of how they treat this in those countries. You can see this worm moving around underneath your skin. And what they will do is make an incision ahead of where they can see that worm traveling, and then they'll pull that worm out. But it is a worm. If you break a worm, the worm can regrow its body parts. So they can't just yank the whole worm out at once because the worm will break and then they'll still end up with a parasitic worm. So what they'll very often do is start rolling the worm around a stick, and every day they'll roll the stick up just a little bit more, so they slowly pull the worm out over time so that it doesn't rip in half and then still lead to infection. There's actually, it's medical lore at this point. Who knows if it's true or not? But I don't know if you guys have ever seen the symbol for medicine. It's called a caduceus. It's the two snakes that are wrapped around like a sortie type of thing. It is believed by some that that symbol came about because of the stick with the filarial worm that gets wrapped around it in developing countries where they still, to this day, get parasitic worm infections. Let's see, after that you just have what I've called group work, and group work of course can't happen as easily when we're all doing online stuff, so instead of considering it group work, you can sort of consider them challenge questions and just see how you could do at those things. And then at the very end I have a thing that says pair up. We really do that pulse activity in the lab, and so I'm not going to worry about that one all that much. And I think at the very end, you guys still have a thing that I have called the circulatory assignment. Instead of doing that page at the back of the notes, I'm just going to put a quiz online for you guys to take as related to the circulatory system. So look for that quiz.